Okay, kids, here we are. This was bugging me. As soon as I was teaching it, I was thinking, I'm not too sure this is a correct way. So here's what we're going to do for this particular problem. This is example number two. So we're going to go back real quick to example number two, and I need to fix or give you a better way to make sure you know which way that this thing is going. We know, or you should know, that there's a vertical asymptote at 2. Nothing cancels out. So there's a vertical asymptote at 2. And so they're wanting you to write the left and right statements as x approaches 2. And so I apologize for this, but I don't have a pencil. So I've got to use my finger. And this is going to be bad. But we'll go with it, okay? And then limit as x approaches 2 from the positive side of f of x. Hopefully this is not new to you. Guys, what I'm going to do, I think the best way to do this is plug in a number just before 2 and just after 2. And I don't mean an integer. I mean like 1.99. I know this is maybe confusion to you, but just bear with me. Plug in 1.99. So if I plug in 1.99 up here, okay, then that's going to be a positive number, because 1.99 minus 1 is 0.99, so that's positive. 1.99 plus 3 is also a positive number. And then 1.99 minus 2 is a negative, really small number. So I've got a positive and a positive and a negative. And a positive and a positive and a negative is a negative, and it's over a really small number. And so as this number right here, as the denominator keeps getting smaller and smaller and smaller and smaller, because really it's 1.999999999, which is like 0.000, right? So this is really, really, really small number. And we take a really, really small number and you divide it by anything, you're getting a really, really, really big number. And so you got a positive and a negative, which has to make it a negative infinity. Whoops, I'm sorry. I told you I don't have my fingers. Okay. And so negative infinity. And then what I'm going to do, let me erase all this so I don't try to confuse you. Now I'm going to plug a number just on the other side of 2, 2.0000001. So 2.001, well, that's going to make this a positive number. And 2 points going to make this a positive number. And then 2.0001 subtract 2 is like 0.0001. So that's going to be a positive number that's really, really, really small. Okay? And so you got a positive and a positive, positive, which makes a positive. And positive over a really, really, really small number makes a really, 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 really big number. And so that's going to be infinity. I think this is the best way to do it. You're just going to have to use some mental math. So any number over a small number has to be a big number. Right? You divide 200 by 1, and that's 200. 200 by 0.5, that's 400. So as this bottom number is getting smaller and smaller and smaller, it doesn't matter what the big number is, it's going to end up being a really, really big number. All right, so let's look at B. Well, you got an x minus 1, or I'm sorry, an x minus 2 and an x minus 2. That's going to cancel those two out. So I'm going to go ahead and cancel those out. That's a hole. It's a hole at 2. That has nothing to do with approaching. Oh, I'm sorry. I apologize. We did this one in class. So as I'm approaching 2, this is a hole. That's what they want me to approach 2. I thought they might want me to approach 3, the vertical asymptote. So as I'm approaching 2, that becomes 0. So it becomes 2 plus 4, which is 6. And then 2 minus 3 is negative 1. So that's negative 6. And so both of those should be negative 6 after you write the limit statements like these over here. Okay. If they wanted to, as it approaches 3, right? Let me change my color. As it approaches 3, if that's what they wanted, then I would plug in 2.99 and 3.01 and see what happens. And you can go ahead and cancel those out because they're going to be the same thing over itself. Yeah, it's going to be the same thing over itself. Yeah, go ahead and cancel that out. I had to think for a second. Okay, so the last one. Let's look at the last one. Let's change colors again. Give me this. Okay. So we got an x minus a 2 and another x minus 2, but there's only one of them, so that still gives me a vertical asymptote. So I got a vertical asymptote at positive 2. Vertical asymptote at positive. I also have a vertical asymptote at positive 1, but they don't even care about 2. So left limit as x approaches 2 from the negative side of, that's h of x. How about that fancy looking thing? And then the limit as x approaches 2 from the positive side of h of x, okay? So again, let's just plug in 1.99999. So 1.99999 gives me a negative up here. 1.99999 gives me a negative down here. And then 1.9999 gives me a positive up here. Okay? And so 1.99999, it gives me a 0.99999. And as this number keeps getting smaller and smaller and smaller and smaller and smaller and smaller, I'm going to be multiplying it by something that's going to be smaller and smaller and smaller. So we're just going to get, you can get a bigger number, but it's still going to be really, 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 really small. And so you got a negative over and times a positive. So that gives me a positive, really, really small on bottom. So that's going to be infinity. So this is going to be infinity. And then I'm going to do 2.001. And 2.001 still gives me a negative up here. 2.001 gives me a positive right here. And it gives me a positive right here. And a negative and a positive and a positive is a negative. And so therefore you got a negative infinity here. Okay? Hopefully that helps you with those questions and those 3 questions from homework. Thank you guys. And I apologize for that. I knew when I was going through that I thought we were going to have to find numbers besides those integers. And I can kind of explain that, but let's just say I have a vertical asymptote at 3. Okay. And then I have a horizontal asymptote. Well, if I come up with a positive, it matters if I'm up here or down here. But both of those are still positive. And so if they're both still positive, I still don't know if I'm going up to infinity or down to infinity. And so we have to go just on the other side of the asymptote to where it makes it a really, really small number. And then we can tell if it's going to be a positive infinity or negative infinity. I think that's going to help us out with those questions. Thanks, guys.